Now let's talk about solving quadratics or quadratic equations. So we're going to mostly just talk about how to solve it using factoring for this lesson. First things first, let's talk about what quadratic equations actually are. So quadratic equations are very similar to polynomial equations, except it's going to be in the form of ax squared plus bx plus c, and it's going to equal 0. That's what makes it the equation. It equals 0. Good. Uh, a, b, and c are all going to be real numbers. A can't be 0, because if a was 0, if you notice, then it would just be linear, right? Bx plus c. That would just be a linear equation. Another way that we could call a quadratic is we could also call it a second degree polynomial equation. And obviously, hopefully we all know now the reason why it's called a second degree is because the degree is 2 of this polynomial. Good. All right. Now, let's look at the zero product principle. This is going to be very, very important. I have people in calculus who still, for some reason, can't get this. So if you can get this now, it'll be way better. All right, so if we have the product of two algebraic expressions equaling to 0, then at least one of these factors, what? Well, let's think about this. All right, so if A times B equals 0, right? Could A and B both be positive? No, because that would be positive. So that's not 0. Could they both be negative? No, because two negatives equals a positive, and that's not 0. Could one be positive and the other be negative? No, because that would be negative, right? So then what's the only thing left? If two things multiply to get you 0, then what that means is that at least one of them equals 0, right? That's the only way that we can get it to where something multiplied by something else is 0. It's only if one of them is 0. Right? So if A times B equals 0, then either A equals 0 or B equals 0. And that's how we're going to solve by factoring. So here's the strategy. Here is how we solve quadratic equations by factoring. So if necessary, make sure we rewrite it in the form. Having some technical difficulties. There we go. All right, we rewrite in the form of ax squared plus bx plus c equals 0. Moving all the terms to one side and obtaining 0 on the other. So if you have a square, that might be a really good thing to try. Get everything on one side, get 0 on the other side. Then we're going to factor. After we factor, remember we're going to have something times something equals 0, so we can use that 0 product principle, setting each factor equal to 0. And then step 4, we solve the equations that we just made, formed in step 3, and then we can check our solutions. So let's look at some examples. So example number 1, 3x minus 1 times 3x plus 2 equals 0. So step 1 is to put it in the form ax squared plus bx plus c equals 0. But if you notice, step 2 was the factor. So if we don't want to have to just undo it and then redo it, right, because this is already factored out, so we can just skip on ahead to step number 3, right? So you don't need to put it in this form if it's already factored, right? If it's already factored and equaling 0. So step 3, let's do the 0 product principle. Oh, once again, having more technical difficulties. There we go. Right? Which means we're going to set each of them equal to 0. So 3x minus 1 equals 0, or x plus 2 equals 0. So we have two equations. And we need to make sure, step 4, to solve each of them. So the first equation, 3x minus 1 equals 0. So hopefully we can see that that just means x equals 1/3. For the second equation, x plus 2 equals 0, which means x equals -2. And these are our answers. So our solution set, we notice, is going to be two different equations, or two different numbers, 1/3 and -2. And that's it. We're done. So let's look at the second one. All right. So example number 2. Step 1, it's already in our form, so we're good. Step 2, factor. So let's factor. So we can't take anything out of everything, so that doesn't work. However, there's 3 terms. The first term is a not 1, so we're going to have to do this factor by grouping. Right? Need to make sure we get that middle term. So what two numbers multiply gets you -8, adds gets you +7. So hopefully we can see that that's -1 and +8. So we rewrite it. 2x squared minus x plus 8x minus 4. All right. So we can group these up. What comes out of the first term? We see it's just x, and we're left with 2x minus 1. What comes out of the second term? We see it's 4, and we're left with 2x minus 1. All right. Then out of both of these terms, we see that we can take out a 2x minus 1, and we're left with an x plus 4 equals 0. All right, so we factored. So let's give us a little more space. So step 3, you use the zero principal property, or zero product principle, excuse me. Right, so we have two equations, 2x minus 1 equals 0, and x plus 4 equals 0, right? Here's our product of two different terms, so we set each of those equal to 0. And then step 4 is solve. So in the first case, 2x minus 1 equals 0, we get x equals 1/2. Second one, x plus 4 equals 0, x is -4. So our solution set is 1/2 and -4. Let's look at some more problems. All right, so we have 3x squared minus 2x. So something that people typically want to do, especially in all of my upper level classes, what they want to do is they want to divide by x to both sides. However, you can't do that. Because x, what if x equals 0? Right? If x equaled 0, could you divide by x? No, right? So dividing by x is not the way we do it. So we're just going to go step for step, right? Step 1, get it in that right form. ax squared plus bx plus c equals 0, right? Get everything over to one side. So if we do that, we see we have 3x squared minus 2x equals 0. Step 2 is to factor. So we see that we can factor out an x in both of these terms. And we're left with 3x minus 2 equals 0. And now we have a product. So since we have a product, we can use our zero product principle. Oh, there we go. So we have x equals 0 and 3x minus 2 equals 0. Step 4, solve. Well, x equals 0. Cool, we're already done. In the second case, 3x minus 2 equals 0, so x is going to equal 2/3. Which means our solution set is 0 and 2/3. All right. Now again, it might be good now that we've got a couple under our belts, maybe see if you can do the examples on your own, pause it, and then see what I get at the end and see if you get the same thing. So x squared equals 6x minus 9. So step 1, move everything to one side. Step 2, factor. So what two numbers multiply gets you 9, adds gets you -6. We can see that's -3 and -3. Step 3, use zero product principle. So each of them is going to equal 0. Step 4, solve. So in the first case, x equals 3. Second case, x equals 3. Which means that our solution set, it's not, we don't put both 3's because there's only one answer, right? We see that it's the exact same answer. So the only answer we get is 3. Good. Next. All right. So step 1, move everything to one side. Step 2, factor. So if you notice, this is a difference of squares. Right, we get 3x squared minus 4 squared. So we can just have 3x minus 4, 3x plus 4 equals 0. So step 3, set them both equal to 0. Step 4, solve. So in the first case, we see that x is positive 3/4. Second case, it's negative 3/4. So our solution set is going to be positive 3/4, negative 4/3. Another way to write this, since it's only the difference is positive and negative, you could also write as plus or minus 4/3. Either one of those solutions is okay. All right, let's look at number 6. So we have it already factored out, but it doesn't equal 0. So we got to move everything off to one side. So step 1, move everything to the other side. So x minus 2, x plus 3, minus 6 equals 0. But it's not in our form of ax squared plus bx plus c. So we actually do have to distribute these out, right? So we have x times x plus 3 minus 2 times x plus 3 minus 6 equals 0, right? So it's x times all that, negative 2 times all that. Then we get x squared plus 3x minus 2x minus 6 equals 0. So we get x squared. We can combine those two to get plus x and combine those two to get minus 12 equals 0. Then we factor. So what two numbers multiplies gets you negative 12, adds gets you 1. And hopefully you can see that's positive 4, negative 3. Step 3, set both equal to 0. So we have two equations equaling 0. Step 4, solve. So x is going to be negative 4, x is going to be positive 3. So our solution set is 3 and negative 4. It doesn't matter which order you put it in. All right. Looks like we got 2 more, and they're just word problems. So if you want to go to your word problem section, as soon as we finish this, we are done with this lesson. So problem 1. You throw a ball straight up on from a rooftop 160 feet high with an initial speed of 48 feet per second. This is the formula we end up with. And this describes the ball's height, h, above the ground in feet, t seconds after you throw it. The ball missed the rooftop on its way down and eventually strikes the ground. How long will it take for the ball to strike the ground? All right. So what letter are we trying to solve for? Are we trying to solve for h or are we trying to solve for t? So we look at our question. How long will it take for the ball to hit the ground? Hopefully you can see that that's a t question, right? time? How long? So we're trying to solve for t, which means that we should have an h. So what is our h? How long does it how long does it take for the ball to hit the ground? If it hits the ground, what's h going to be? So hopefully you can see that since h is feet above the ground, at the ground, h is going to equal 0, right? So we have 0 equals negative 16t squared plus 48t plus 160. All right, it's already there. It's already in our form, so we just got to solve for t. So step 2, let's factor. So let's try to factor out the big numbers first. So it looks like we might be able to factor out a negative 16. So that's going to be t squared minus, so let's see, I think it's multiplied by 3 to get us 48. So 3 times 6 is 8. Carry the 1, 3 times 1 plus 1, 48. Cool. So 3t minus, and we can see that's clearly just 10. All right. So we get, oh, technical difficulties again. Whew. There we go. So how can we factor this out? What two numbers multiply gets us 10, adds, gets us negative 3. There we go. So that would be negative 5 and positive 2. Again, doesn't matter what order you put it in because we're about to make everything equal to 0. All right, so from here, there's a couple ways we can think about this. So we have 3 different terms. So you could just set all 3 terms equal to 0. So you can make 0 equal negative 16, 0 equal t plus 2, 0 equal t minus 5. That's totally okay. And as you can see, that's impossible. 0 can't equal negative 16. So we're left with the other 2. Another way you could do it is from the beginning, you could divide out negative 16. So if we divide everything by negative 16, since it's a product, right? The same way that we would divide a 2, right? And it doesn't affect anything. It would just be 0 equals t, right? We could also do it that way. If we divide everything by negative 16, we're just dividing this, right? So we end up with 0 equals t plus 2, t minus 5. Or even another way. So if you already found your ways, that's cool. But this is another way that I found students like to do. So they just set this as one term. So they let negative 16 times t plus 2 equals 0, and then t minus 5 equals 0 as our 2 terms. Whew, my computer is just not wanting to write anything today. All right. And then from here, right, we can divide both sides by negative 16. So we get t plus 2 equals 16. Again, computer's just not working today. There you go. And then we end up with the same thing regardless, right? Which would be t is negative 2 and t is 5. All right, so these could be both of our answers. However, let's think about this in the context of the problem. What does t mean? T is seconds after you throw the ball. Can you have negative 2 seconds? No, that doesn't really make any sense, right? So 5 has to be our answer. So the ball will hit the ground after 5 seconds. Good. All right, last problem, and then we're done with this lesson. So an architect is allowed no more than 15 square meters to add a small bedroom to a house. Because of the room's design and the relationship to its existing structure, the width of the rectangular floor must be 7 meters less than 2 times the length. Find the precise length and width of the rectangular floor. So if you remember, we can do our steps when it comes to step for step, how do you do word problems? So step 1, let x represent one of the quantities that we're trying to find. So it doesn't matter. We're trying to find length and width, so let's just let x be the length. Step 2 represents the other unknown in terms of x. So the other unknown is the width, right? So we say that the width must be 5 meters less than 2 times the length. 7 meters less than 2 times the weight. So less than is another word, is another way to say subtracted from. So you could also say 2 meters subtracted from 2 times the length. So we said the length was x, so 2 times the length minus 7 is going to be our width. Number 3. Write the equation that models our condition. So what else do we know about this problem? What else does the problem give us? Well, it told us that it's no more than 15 square meters, right? So 15 square meters, that's going to be area. And area is just length times width. So that means that 15 equals the length, which is x, times 2x minus 7. And then step 4, solve. All right, so we've been doing this all day. We can do this again. Need to get some more space. There we go. So move everything to one side, right? So we get 0 equals x times 2x minus 7 minus 15. This isn't in our form, right? We need it in the form of ax squared plus bx plus c. So we can just distribute both of those. So we get 2x squared minus 7x minus 15. All right. To factor, we'll need to do it by grouping. So what two numbers multiplies, I guess we can use the black, make it a little different. What two numbers multiplies gets you negative 30, adds gets you negative 7. And if you go through all of them, hopefully you can see the two numbers are going to be negative 10 and positive 3. All right. So we rewrite it. 0 equals 2x squared minus 10x plus 3x minus 15. Group it up. There we go. We can take out a 2x from the first one, left with x minus 5. We can take out a 3 from the second one, end up with x minus 5. We can see in common with both of those is going to be x minus 5. And what's left over is 2x plus 3. So we have factored. Step 3 in this process of factoring, or solving by factoring, is to use the zero rule property. So we have x minus 5 equals 0 and 2x plus 3 equals 0. And then we solve. So in the first case, x equals 5. Second case, x is negative 1/3. So we have to try both of them. This part is actually probably going to be what we need, right? We need to check both of our equations to make sure that one of them works. So we said that the length is x. So if the length is x, then the length can be 5, right? Which would mean that the width we said was 2x minus 7. So in this case, it would be 2 times 5 minus 7, which is 10 minus 7, which is 3. So in this case, the length is 5, the width is 3. Let's check the other one. And the other one, we say the length is x, so that's 1/3. In the second one, the width is 2x minus 7, right? So that would be 2 times 1/3 minus 7, which is 2/3 minus 7. And if you notice, this is going to be a negative number, right? Because that's going to be the same as over 1. So we can multiply that by 21 over 3, right? And we end up with negative 19 over 3. But can you have a negative width? No, that doesn't make any sense, right? So this one is not the case. So remember, we said that one of these can equal 0, right? And what it turns out is that the x minus 5 is the one that's going to equal 0. So we can see that the length is 5 feet, or 5 meters, excuse me, and the width is 3 meters. All right. If you have any more questions, let me know, but this is the end of this lesson.